Hey, it's Eric Newcomer. Welcome to the Newcomer podcast. This week I have Delian Asparouhov, the co-founder of Varda and a partner at Peter Thiel's Founders Fund. Varda has sent a satellite into space and is planning on manufacturing drugs there. A really exciting company, and we dig into space startups more broadly. Give it a listen. Before that, a word from our sponsor. This episode is brought to you by Juniper Square. It's time to let go of the disjointed technology used in venture and private equity today. More than 1,800 GPs now rely on Juniper Square to manage over $700 billion in investor equity. Juniper Square offers a unified solution for fund administration, fundraising, and investor operations. Work with an institutional-grade fund administrator you can trust and get a shared source of truth for all your fund and investor data. Learn more at junipersquare.com. That's JUNIPERSQUARE.com. Juniper Square. Thanks so much. Now for my conversation with Delian. Delian, welcome to the Newcomer podcast. Thanks for coming.
Thanks for having me, Eric.
Where I assume you're at Varda right now. What's the background scene here?
That's basically our facility in the background. So this conference room has a nice viewpoint, and it happened to be the only one that was available right now. So,
where is the facility?
It's about 10 minutes south of LAX in this town called El Segundo on Aviation Boulevard. It's literally like a boulevard that is filled with we're on the same block as the Space Force's headquarters here in LA. There's an Air Force base down the street. Northrop Grumman, Raytheon, et cetera, all have offices within a quarter of a mile.
When did you open it up?
We moved in this office May 22, so call it a year and sort of 2-3 months ago.
And how many people roughly are working there?
Right now, we're about 83, 84 people full-time. I think that's with interns and everything, maybe gets up to 86, 87, somewhere around there.
Has it hit you? I feel like I run this little newsletter business, I have an employee, but I feel like being at home really changes the vibe. And then when I go to a friend whose company has an office and he's lording, it's intense. And then when I see this, I'm like, oh man, that must really hit you. Or what was it like to open up an office like that?
At the time, I think it was actually more existential terror in that, it was going to be a massive expense in that when we were considering the lease and actually signing it, the amount that it was going to increase our burn was definitely not insignificant.
Right.
And I definitely at one point, I think this is the first time I'm revealing this publicly. There was actually a point where after we had already signed the lease, I almost wanted to back out of it because I was we're not ready. The company isn't going to do well enough to justify this. This is going to be the thing that kills us because we moved into a too big of an office too quickly. And then I actually called Matt Grimm, the COO over at Anduril, and I was like, bro, how the fuck do you get comfortable with this level of monthly burn just on the office? You're not even accomplishing anything. This is just house the people. Let alone actually invest into the hardware and the things that our customers are actually paying for. And I think he was like, look, you just you're building a startup, Del. You have to bet on upside and the fact that it's going to work. If you keep thinking about what's going to happen if it doesn't work, you're never going to give yourself the opportunity to work. And you guys are clearly packed in sardines in your prior office. It's a lot of effort for this type of company to switch offices. This isn't a SaaS company where you're just swapping over a bunch of laptops and desks. You can kind of see it. There's a bunch of equipment out there, and that equipment is not something that you can hire Joe's Movers to go move. That is equipment that needs to be uninstalled by a highly skilled engineer or technician and then reinstalled at the new location. And so if you don't move into an office that you can at least be at for 2-3 years in the upside case, then you're spending a lot of effort, every single year.
How many people could work out of this office?
It depends on who you ask and, what, constraints you focus on. We probably run out of parking at the 130, 140 mark, but we technically could jam in 200, 250 in terms of desks and office space. And so SpaceX did this back in the day where they actually got a parking lot nearby and they would shuttle people. But I guess there was just some level of morale hit because you couldn't just walk out of the office and go to your car. You had to walk out, wait for the shuttle, then get to your car, et cetera, even at a relatively small scale. So anyways, we have to figure that out. But I feel confident we've got at least another 2 years at minimum in here, and we've already been here for a year and a half. And the goal was it needs to be just something that lasts at least 3 years. So I feel pretty good about even if we do have to upgrade in 2 years. I think
you tweeted that you had a month where you're July maybe where you're cash flow positive. Is that right? What does that mean exactly?
Technically, it could mean that we just like received investment dollars and that was what caused our bank account to go up. The like, very simple term of it is just like if you look at, sort of cash in the bank, the 31st of the prior month and then the 31st of the next month, did basically like cash go up or down? It's a very...
So it was about investment dollars or...
It was not. I'm just saying, in theory, one could have,
Sure.
Done this with investment dollars. So that's why it's not that important of a metric because it confounds many different variables, right? It's nothing like free cash flow positive or EBITDA positive, et cetera. This is why you have these types of terms because you can't build this type of business just that simply. However, ours was a customer payment from that Air Force contract that we announced earlier this year. And that payment was larger than our total all-in burn that month. And so our bank account did go up because of customer payments.
That's great.
Yeah.
Okay, we'll talk more about Varda in a bit. LK99, the idea that there is a superconductor at room temperature, people think a new maglev type train or certainly consumer electronics, you're working in space manufacturing. I'm sure you're thinking of tons of different ways you could put it to use. What was your initial reaction when you sort of read about the research paper in the first place?
For the first 24 hours, it was definitely sort of like extreme curiosity. My first reaction was go to our chief scientific officer, whose prior background was actually at this company called Lam Research that does, phenomenal world-class material science and helps basically bring mostly semiconductors to market. So he has a really strong background in the, sort of exact type of, sort of physics materials that the superconductor was based off of. And so my first reaction was like, this could be a fraud, but let me just like go ask our chief scientific officer. And his response was like, there's a there. Like, I don't have the time right now to like, dig into this and validate it. But like at first glance, it's definitely possible. And so then I was extremely excited for the first 24 hours.
Did you tweet something negative about it or I forget? No.
I don't remember exactly. I know my emotional states at the various times, but I don't remember my like tweets at the various times. For the second 24 hours, I was extremely skeptical because there was a handful of I think like, if I'm remembering, it was like certain graphs in the original like Korean paper just had some weird anomalies that made it look like it was fabricated data. The authors then did eventually respond, and basically 48 hours after the paper was published, then the first handful of like sort of supportive comments started to come in, and some of the dynamics around like the co-authors, why the drama there started to come out as well. So then I sort of got like more and more bullish, and then basically have generally gotten more and more bullish basically since hour 48. So it was an interesting roller coaster where it was like first 24 hours elated, second 24 hours really depressing, and then steadily basically improvement over the past like sort of 10 days or so in terms of my
and I mean you guys
interest
replicated it, right? I mean basically in some form, or what motivated you to sort of actually spend company time on it?
Yeah, I believe we were the first, at least like sort of public verifiable attempt at the replication. I still think there's work to be done to verify whether did we perfectly replicate it, did we get a sample, et cetera. Obviously there's work to be done, but
you had little things standing up basically, right?
There were some, and those could be explained by different effects potentially. I'd still say I think there is a decent likelihood that we had some non-just standard iron filings ferromagnetic sort of sample in there. There was some sort of either extremely strong diamagnetism, which is weird in and of itself, a 1D superconductor, or potentially actually superconducting material in those samples. But yeah, we were the very first, basically, I believe again publicly disclosed and verifiable Western, let's say NATO country replication attempt. Why did we decide to do it? This was definitely much more nights and weekends project than it was like a whole company project or anything like that. But yeah, there's just like a handful of engineers that in the first 24 hours recognized that because of the type of chemistry that these Koreans were doing and the skills that were necessary for it, it had a oddly weird overlap with the work that we do at Varda in relation to biopharmaceutical solid state formulation. And so we had all of the necessary equipment to do the replication already in our facility, and that some of the precursors were obtainable within, call it 24 hours to 3 or 4 days via sort of commercial supply chains. So yeah, we basically decided, a handful of the sort of engineers said, hey, let's like try and do nights and weekends replication of this. Obviously, our chief engineer Andrew McCaleb got a ton of attention on Twitter as he was publicly documenting.
Great recruiting, marketing, certainly at worst case scenario.
Yeah, it's, if you can see what we can do nights and weekends over the course of 8 days, imagine what we're doing here day in, day out. Yeah, we're really happy with, sort of how it portrayed the company over the past, 8-10 days. And then at this point, definitely sort of, handing off the project to sort of the academic and national labs where this type of work is sort of more appropriate to be done.
The goal is to produce like the Meissner effect, right?
I would say the goal is to produce superconductors, and then obviously an effect that superconductors have could be the Meissner effect, but there's a wide set of applications of superconductors.
I mean, right now it sounds like you're like, this is back to academia. You're not like, oh, this is going to be important to Varda in any meaningful way in the next couple of years, or...
No, this stuff is, where the transistor was, in the, very early days. There's still a lot of work that needs to go into experimenting around the formulation of this, getting the yields higher, understanding how to get this from right now, what is crumbles of rocks into something that can actually be used commercially, right?
Right.
Even the original sort of high temperature, they're called high temperature superconductors, but the things that, can, operate at the, temperatures that liquid nitrogen is at, those took over a decade from initial discovery to actually large scale commercial use. And now they are used every MRI machine in hospitals, Commonwealth Fusions, Bill Gates' fusion company utilizes them at, significant scale. But yeah, that took a sort of decade plus. And so it's just, we're fundamentally a venture-backed, commercial company. Basic research is not necessarily the best place for us to be doing this. I do hope somebody, I was, texting with a friend earlier, Lockie Groom, about how somebody should create the equivalent of fast grants for COVID, but, for LK99, where it's this stuff is more fundamental basic research, but it could probably be done best outside of a truly traditional academic or national lab setting, but it needs to be somebody that's just funding it for goodwill, because you're not going to see return on that capital for 5-10 years, potentially longer.
After our conversation, Delian tweeted, "Alas, the rocks we made floated due to iron impurities. We did confirm we were able to synthesize the lead apatite lattice. So it's not looking good for room temperature superconduction." I'm glad you brought up COVID, because it felt on Twitter or X or a lot like that moment where Silicon Valley felt like it had caught on to something in a way that the rest of the world can sort of feel flat-footed, right? And clearly with COVID, it panned out big time and ended up being a big prediction. It's harder to tell this, to some level, there's nothing wrong with just enthusiasm on Twitter. It doesn't necessarily have to be world predictive. I feel like in the case of COVID, it became sort of a test case for, media blindness and sort of Twitter accuracy. But yeah, you see the connection in what I'm getting at there. I'm curious, how predictive does this have to be? Or is it just it's fine to be enthusiastic here, regardless of whether this is a world historical event? Or how much do you take sort of your enthusiasm here to be a sign that this is truly a significant research paper?
I think at this point, it's pretty clear that this was, sort of a field of academia that was somewhat discarded after the Soviet Union collapse. They were by far the sort of world-class, in this particular, call it shake and bake chemistry, sort of alchemy. That's partially why you see the, sort of Russian, cat anime girl, Iris GB. She actually studied under one of the last Soviet Union professors that previously, had a lab that was running this. And then the Koreans also had a connection to that original, sort of last, standing Russian lab. So I think it's sort of pretty clear that this is a, sort of academic field that needs to be revived. And in some ways, again, borrows a lot of, sort of analogies and potential techniques from the biopharmaceutical world around. You can just make these very disparate, unique solid state formulations. They're very difficult to predict in terms of how they interact, but they can have these very weird sort of effects. And again, it was just something that hasn't been a field of study, because it's one that is not particularly theoretically sexy in that it's a very practically applied
right.
Sort of science. And then after you create things, you may be able to understand the theory behind them.
To dumb it down and tell me if this is wrong, but it's you're saying in medicine and drugs, it's there's a lot of value in sort of coming up with random drugs that might have uses without a clear theory behind them.
Why?
Right. And similarly here, we could have an awesome material that could be really good for industry without it proving something about science that people are necessarily pursuing.
Yeah, the biopharma world has no ego around. We're just going to throw shit at the wall and see what sticks, basically. And then afterwards figure out basically what's going on. And in materials world, for some reason, especially around superconductors, that just hasn't been the way that people have, sort of thought about things. And so I think, what this has unlocked is, or I would hope that it unlocks is that the NSF funds $1 billion to basically create, if you look in the early 2000s, especially around small molecules, which is the, sort of primary drug category. If you think of something like ibuprofen, it's a small molecule. In the early 2000s, there was a ton of effort basically around doing basically mass scale robotic creation of small molecules and screening of them. So rather than having to basically like rely on individual basically scientists doing pipetting and process control and things like that, you'd instead have this like mass scale screening. And now there's like an extremely standardized, like commoditized offering, even so much so that like we actually exported a decent amount of it to, the Chinese, like companies like Wuxi, for example. This is basically like their, sort of bread and butter is like doing this stuff as like a service. And so one would hope that basically the NSF is recognizing, hey, there's a parallel pattern here. We actually need to invest like $1 billion into incentivizing people to actually go create this type of, mass scale robotics. And it is going to have to look very different than biopharma. If you think about the temperature ranges, the types of elements that you're working with, they're very different than what you're working with in, sort of biopharma. These things are obviously like non-organic, metal compounds that are being done at much higher temperatures. Some of these things have explosive properties. And so there's definitely like somebody needs to go create a robotic facility that does this stuff basically like, at scale, safely to go figure out what is eventually that chemistry that really does produce like kind of like the blockbuster result. And then that's the thing that one day can get commercialized. But, if I had to like put finger in the air, guessing on timeline, it's like minimum 2 years, probably closer to like 5 years for that infrastructure to get built, somebody to find that formulation that actually is sort of viable. Then it's going to like begin the commercialization, and like, the early places will probably just be where superconductors are already used today, like MRI machines, like fusion, et cetera. And it's going to be like a ways away until like you have like, I don't know, consumer floating skateboards or, whatever you want to, think about.
Okay. So Varda, what is your focus at the moment? What are you trying to build today?
So our goal is to basically take some of the research that's been shown on the International Space Station to have a ton of promise in terms of, like we've been talking about, solid state formulation. It turns out solid state formulation is significantly affected by gravity. That may also be true in superconductors. So one day down the line, if somebody does discover these formulations and they're showing issues that we think gravity can actually solve, there's a world where Varda flies a superconductor in, 4 or 5 years, but definitely not anytime soon, given that the biopharma side is so much more sort of proven.
Sorry, I'm going to be dumb again. To me, solid state, I think of like hard drives. Is that, or what do you mean solid state formation?
Oh, yeah. So if you look at basically what's happening both in the superconductors and what we do in like biopharma world, you're basically taking things that were previously like very fine-grained powders or liquids. You're basically making solid-state crystalline like versions of them. And so in the biopharma world, that ends up looking like a little bit of table salt that you take, and it turns out that thing actually has like a drug cancer molecule in it or mRNA molecules. In the world of superconductors, it turns into these things that look like, I mean, you've seen them on Andrew's Twitter. They look like these kind of like weird half ceramic, half metally, shiny, kind of objects. So solid state is just what form is the matter, sort of in, and solid state in particular typically means it's a larger crystalline lattice structure, not just like individual small
and the
atoms.
Thesis then is that solid state manufacturing is easier in space.
Yeah, basically, when you think about what is solid state manufacturing, it's not just the individual atoms, right, being solids themselves. It's specifically what is that crystalline lattice structure that is formed as you're like melting down. This is why, for example, the superconductors are having this like yield problem where you have these like, lead and then these like copper phosphorus, atoms. Occasionally, they happen to arrange themselves in just the perfect state where they like, appear to potentially be creating a superconductor. You sometimes see the same issues in biopharmaceuticals where things arrange themselves in just the particular state where it then allows it to be like dissolved in your blood or delivered through the blood-brain barrier, or allows it to be shelf stable on a shelf at a pharmacy. And when you go up to gravity, basically what you remove are what are known as convective currents. And so to explain those sort of really quickly, if I basically light a candle in front of me here on the desk and I put my hand above it, I'm basically taught that as a kid, hot air rises. Why is that actually happening? You basically have this like combustion reaction. It's creating thermal energy. That atmosphere around it is basically becoming less dense because it's basically got that thermal energy getting transferred to kinetic energy. And when you're in a gravitational field, right, less dense gases or less dense liquids move to the top, right? This is why you're taught as a kid, again, the hot air rises. So let's take that same candle. Imagine you and I were on a space station. I light it, in front of us. What actually happens? You still can light the candle, and it's still basically like, we'll start that combustion reaction. The gas around it still gets hotter and actually, becomes less dense, but there's no gravity to make it like go up or down, right? And so what ends up happening is instead, basically that gas just very steadily diffuses throughout the entire room. So think about, both again, and this is why it's been kind of fun. This is the first time actually talking about both in parallel, but it applies to basically both, right? Imagine you have a bunch of lead or copper atoms, or you have a bunch of like, carbon and oxygen and hydrogen atoms or whatever you have in biopharma land. If you are thinking about what is a solid state formulation, you're basically typically applying some level of like thermal energy to disparate atom structures, and those atoms typically have different weights. And so the lead might end up starting to move faster or slower than the copper does. And so because that one's less dense than the other, and so just like on a candle where you have that hot air rising and then you actually have cold air coming in, typically at these like crystalline lattice scales. So not at like the super microscopic scale where it's just like two atoms attaching, but you're thinking about hundreds of atoms and how they form lattices. They're like dominant, basically like what's known as like a transport mechanism, or basically like the dominant factor that affects how these atoms arrange themselves when you're in a gravitational field is convective pressures. So basically like how do they move, due to the thermal, pressure, versus when you go up into zero gravity, there is no up, there's no down, there's no convective pressures. And so instead you can actually heat things up and they just stay in a very basically like stable state. So in some ways you can kind of arrange them how you want, heat them up, cool them down, freeze them basically in that solid state form that you want, and you don't have these basic convective pressures constantly moving them around. So this has been, proven on the International Space Station in the world of biopharmaceuticals, decently well. So one of the blockbuster results was done by Merck, by the scientist Paul Reichart. He basically showed that Merck has this blockbuster drug, Keytruda. It does $25 billion a year of revenue for them. Right now, it's a monoclonal antibody biologic. Basically, it's a drug that is very large. And a simpler way of saying it. And when this drug that is very large, they try to make a solid state form of it, because it's very large and basically flops around, it moves a lot when it's being basically crystallized, because it's particularly large.
Does Merck make it in space, or they just showed they could, but they end up making it?
Merck currently makes it on the ground, and when they make it on the ground, it flops around so much that it makes these really large crystals that basically are very varying in size, diameter, etc. And so because of that, it's difficult for them to control dosing when they give it to a patient, because it breaks down in disparate rates in your blood. And so you end up having to go into an intravenous clinic every single day for anywhere from like 1 to 4 hours, and actually have a nurse basically monitoring your dosing so you get it appropriately. They're able to show on the International Space Station when they crystallize it, because you don't have any gravity there, it's not flopping around. And so instead, it basically just forms a bunch of individual crystals that are basically all the exact same size. And so what does that mean? I know exactly how it's going to dose and how much I can give you. So I can then just basically send you home with a bunch of syringes. So Merck and Paul Reichart from Merck in particular proved this out on the International Space Station, but they had no way of commercializing it, because fundamentally a government-run, human-rated space station is not a place where even a company like Merck can say, hey, shut down the Dubai, or shut down Saudi Arabia sending astronauts up there, or the Russians. Instead, let me take over this whole station and do mass manufacturing. Merck both doesn't know how to do that because they don't develop hardware, and NASA wouldn't let them do so. And so Varda's whole thesis was, how do we take those types of results and allow companies like Merck to scale them up? And I think one of the most exciting moments for the company was on the day of our launch, we had a CNN article come out that, unbeknownst to us, the journalist had actually reached out to Paul Reichart at Merck, this world famous, probably the most famous scientist in microgravity, pharmaceutical manufacturing. And he had a quote in there, well, I'll try and roughly paraphrase, which is basically like, the International Space Station was like a great place for me to do my initial research, but there are significant limitations in cost and cadence. I'm really excited by what Varda is working on. We don't yet have a contract, but we're looking forward to basically collaborating.
You heard it here first. Media good.
Accidentally good.
What's your capacity to do this right now, or how close are you to actually being able to manufacture anything in space?
So we sent our first satellite up on June 12th of this year on a transporter mission with SpaceX. So think of those as basically like the ride shares. A lot of what enables a company like Varda to work is the fact that, even 3, 4, 5 years ago, you basically had to book whole individual rocket flights entirely on your own. Those things were massively expensive. Instead, now it can basically do a ride share flight, which, costs anywhere from $5,000 to $7,000 a kilogram. So think about something like Varda that, weighs roughly 300 kilograms. You're talking about us being able to go to space for 1.5 to 2 million rather than 30 or 40 million. So that is something that is possible with a seed and a Series A round, versus obviously previously was very much so not possible.
And you're taking a piece of manufacturing equipment for that much money?
So that is just the ticket, and then yes, we do also have to design the manufacturing equipment and everything. So yeah, on our basically first mission, it's about a 300 kilogram basically total satellite. You can think of it as about a third of the satellite is basically what looks like a standard satellite, basically the infrastructure that you need to operate up there in orbit. So this is everything from solar panels to a satellite radio to communicate with the software down at the ground, reaction wheels that allow you to keep the satellite pointed in the right place, basically all the infrastructure that you need typically for a satellite. The second portion is basically, what you would think of as manufacturing equipment that actually has basically all of the reagents and all the molecules preloaded on board. And then the third part is basically a small reentry pod that basically brings those finished pharmaceuticals, back down.
Amazing.
So we launched on June 12th. We executed that first manufacturing run, I want to say somewhere around July 6th or 7th or something like that. And then we're looking forward to hopefully being able to reenter. Right now, we're still working and collaborating with several of our government and commercial partners to work on bringing the capsule back. But we're looking to hopefully bring it back, call it late August, mid-September.
And somebody paid you, the other companies, you're doing research on behalf of companies and government agencies, or?
This first one was very much so demonstration mission, show our customers that this type of thing is possible, given that, despite the fact that, companies like Merck, have been super enthusiastic about these value propositions, I think they've been actually somewhat skeptical there would ever be a way for them to commercialize. And so they sort of needed, an existence proof of something like Varda actually showing it end to end, before being willing. But
and do we
feel
know,
pretty confident.
Do you know it worked yet? Or, it partially depends on how it comes back, I assume, but.
So we know that the satellite generally worked quite well. We know that the manufacturing equipment, the analogy that my co-founder likes to give that I like to use is imagine that in the world of pharma manufacturing, imagine that it's basically like a kitchen, and in the kitchen you have a whole series of appliances, and you might have everything from a toaster to a convection oven to a blender to a little scale that weighs your various sort of ingredients. On this first mission, we very much so built like a very basic like toaster. It is basically like the simplest appliance possible, right. And all that I can tell you is that the toaster did heat up and cool down as we wanted it to. I cannot tell you whether or not the toast inside got fully burned to a crisp or got toasted appropriately, etc. But generally, as we know, toast does do certain things when you apply certain temperatures to it. Right. So I feel pretty confident that the toast inside is nicely baked. And now that toast also does need to basically survive reentry. So I'd say there were 3 or 4 things we want to prove out on this first mission. We have been able to prove out roughly half of them already, but there are some future things that we need to prove out. But even if the mission were to die tomorrow, we still definitely sort of learned a lot that will make it even more likely that future missions are able to do everything that they need to end.
When's the toast come back home?
Basically, as I was mentioning, sort of working with our government partners to get that sort of fully lined up. We have to work with both the FAA around approval and license to reenter, the Utah Test and Training Range, which is a military range that allows us to basically land in their land, and then Rocket Lab, which is our partner that actually executes the actual deorbit burn, basically the rocket, small rocket engine that basically brings us back from space into the atmosphere. But we're nominally targeting basically a sort of late August reentry date.
I mean, it's amazing. It's a great thing you're doing. I feel like it's such an unambiguously awesome thing to be working on. I feel like from the outside, the whole sort of story of the milestones, and you're sort of talking about, what would be sort of a viable thing, and what it reminded me of the whole SpaceX experience where I forget, it was a couple months ago where one of their shuttles blew up or something. Do you remember that whole, much more about this than I do. I didn't prep this one. It's so hard for the sort of layman world, myself included, to know and believe. Obviously, my experience as a reporter, every company tells you everything that happens in the most positive light. So it's so hard, even when you're cheering for these things, to know sort of as an external observer what is a sign that the company is on track versus what's not, and what's a level I don't know. What was your reaction to sort of, I mean, the media obviously sort of, the New York Times especially framed that the SpaceX blow up super negatively, it seemed, right?
Yeah, I think the layman's view, and in particular obviously the New York Times view, was completely, sort of clueless and off base. What I would generally say, I'll maybe touch on a one part comment, which is I think at least in aerospace, it's a lot easier to publicly verify how a company is doing, in that the, sort of the traction is not oh, we're not going to tell you our revenue numbers, but we're doing well and our software is good. It is did the rocket launch? Did the spacecraft re-enter? Those are physically verifiable facts, or not facts, and so you can't really sugarcoat it as much as you can in software world. In relation to the SpaceX thing, maybe I'll provide a little bit of context here. So SpaceX is trying to develop an extremely ambitious, completely new rocket, right? So they have a rocket that we launch on called a Falcon 9. That rocket is a workhorse. It has not now exploded for 210 or 12 launches in a row, which is by far the most that any rocket has ever done in a row, by far the fastest, cheapest, etc. So they have this workhorse that is the safest thing that humanity has ever developed, and is working really well. Yeah. They are trying to now build a new, very risky rocket, but it is a new rocket that is even more capable. The reason this rocket is particularly interesting is you may be familiar with the Falcon 9 in that it actually lands a portion of itself back onto a landing pad. However, even though this is the best that we've done and it's the cheapest, it still is not perfect in that it still loses basically the top fifth of the rocket every single time. And that's just how it's designed. Basically, that top fifth basically burns up every single time, is a one-time use. So if you've ever heard, Elon's basically imagine you were taking a 747 across the country, and every single time, basically the 747 completely disintegrated when you landed on the other side. Air travel would be pretty damn expensive. Right. So we've gotten better for sure. Imagine that most of the planes survive, but the cockpit fell off every single time. Right. You have to rebuild the cockpit every time. That's basically how rocket travel works today. So we definitely improved. This new rocket that Elon's trying to make is basically the full 747, goes all the way up to space, comes back and lands. It's a very difficult. It's been basically single stage reusable rocket, orbital rocket. So because it's so risky, SpaceX has taken the approach of, rather than certain groups where they get stuck in infinite, decades long of sort of analysis paralysis, they try to engineer the perfect thing. Elon's approach, which has worked very well, if you remember the early Falcon rockets definitely exploded and blew up, his approach has been just, ship things and do it, and you'll learn even from what is perceived as failure. And so if you were to poll most of the Varda team or most of the team at SpaceX that worked on Starship, nobody thought the thing was even going to get off the pad. They thought it was just going to blow up on the ground, basically. before it even managed to get in the air. It made it way further than anybody expected. It made it through Max Q, one of the most difficult things. It basically actually basically failed around stage separation. And so I think to claim that it's like a failure is like insane to me, given that this is like the most ambitious project that like humanity has ever taken on. It did way better than anybody possibly expected. Like people thought it was going to blow up on the ground, let alone up in the air. And then this is just like the state of engineering. Like you need to test things. And obviously if it only works, then you haven't been ambitious enough and haven't been like pushing the way forward. It's like the New York Times framing of it is just like complete cluelessness. To even call it like a space shuttle, failure type thing is like, at first, the space shuttle was supposed to be the workhorse safe thing, and that blew up. That is a different thing. Everybody in the space community knows there are no humans anywhere near that rocket. Like this thing is explicitly in development, right? And in order to get to something that is safe, it originally has to be like unsafe to be able to prove it out and build it over time.
How much does Varda depend on SpaceX's continued success and like bringing down the cost curve? Like could Varda work with the cost of satellite deployment today, or are you counting on sort of further reductions in the cost of deployment?
I would say at today's launch cost, where we're spending the $1.5 to $2 million, sort of per flight, that is, sort of more than low enough for us to be able to build a really strong, sort of business around what we're currently doing today. So I would say none of our business models, the way that we think about the world, are predicated on any sort of future, cost dropping. Obviously, I'd be thrilled for either something like Starship to come online. I think that'll take some time. I'd be thrilled for, sort of more players coming to the market and actually start landing rockets. Nobody's really, sort of done that yet, even though it's been, 8.5 years at this point since SpaceX landed their first rocket. So I'm not counting, on it, happening anytime soon. And we've made sure to architect our business so that it's not, sort of predicated on it.
I'm going to continue my Spaceman explain to Earthman how things work. But, you hear people like worry about like, oh, is the sky going to get too like cluttered? Like we had a UFO conversation that turned into like, oh, satellite density. Like what is the capacity? Like how much more crowded can the sky get with satellites?
A couple of different ways to sort of explain this. First, let's just think about like the Earth's crust. How crowded is it? I'm sure you've flown on a like 747 flight at certain times, and you like stare down into like the middle of like Kansas, or even like you drive. I'm currently in LA. If you like fly 2 hours northeast of here, it is like in a completely empty desert, right? So imagine that you only had a like single crust equivalent of the Earth in orbit, and you had to fit all the satellites on there. Well, the amount of satellites that we've sent are obviously way smaller than what we've built on the entire Earth's crust, and even then, the Earth's crust is pretty like not crowded. And in space, by the way, you have a whole multitude of altitudes that you can be at, right? When you're on Earth, you basically really only be at a single altitude, wherever the crust is, basically. When you're up in space, you can be at 500 kilometers, 600, 700, 800. So imagine a bunch of like shells of the Earth's crust, each of which may hold its own individual satellite. There's a lot of room in space when you think about it that way, especially because the further away you get, the bigger the shell becomes, because like the larger the shell is relative, sort of to the Earth. Now, I'll provide the caveat that things are moving much faster up there. And so because of that, even very small things, sort of coming close to you or hitting you are much more dangerous than like a little pigeon, basically like hitting you when you're like driving along a highway. So there are risks in that. And then the last comment that I'll make is also people underappreciate there are basically these like lower altitudes where things will basically like naturally decay, because space isn't this like strict line of like atmosphere to no atmosphere. It instead like actually like steadily basically decays. And so even satellites that are up in space still actually experience atmospheric drag at certain altitudes. And so they'll basically like naturally decay. So there's sort of like this like self-cleaning mechanism that the Earth has basically for a decent amount of the altitudes that we operate at. Now, once you get up to like geosynchronous where you're super far away from Earth, at that point it's like, I think on the order of like billions of years or something like that to ever like, clean itself. So is it a problem? Like, yes, it is something that like, needs to be managed with. Is it this like existential thing where like humanity's totally screwed? Like, no.
Is it well regulated? Like right now you can like send up a satellite and leave it there, or you need to sort of, you're culpable if your like satellite collides with something.
Yeah, it's not particularly like, there's some light regulations today. And like, I think eventually what you want to get to is basically requiring people that send satellites to space to either deorbit themselves, or they have to set aside capital as a bounty for somebody else to come and deorbit them. So that way you could have basically these like cleanup crews where, I send my satellite for, whatever, $1.5, $2 million, but then I leave a like $200,000 bounty, and then whoever like, comes, grabs me, ditches me in the atmosphere, and they go on to like the next guy can make like money off of that. So I think that would be like the ideal situation, that you have like some sort of regulating agency that handles the verification of that. But that type of regulatory framework require pretty, sort of forward thinking, probably like, like, this is something that it feels like a vice president would be doing, given that typically space stuff falls under the vice president. And so who knows, maybe even in the, whatever next administration, there's a world where whoever ends up being VP, tackles this as a project, because it is roughly starting to become appropriate timing to start to think about, something like this. But yeah, nothing really today.
In the total fun category, and since I referenced it, do you have a view on this UFO situation, or have you spent much time thinking about it?
I admit relative to some of my colleagues, Solana and crew, I definitely have not spent, sort of nearly as much time on this. So I can't claim that my views are super sophisticated, other than there's clearly some weird data. There's also some mixed incentives in terms of some of these people that are testifying in front of Congress might be just doing it for the attention. But, there are also obviously some weird anomalous, videos and things like that have been published. I don't have a strong opinion other than
What's your percentage that the UFOs are aliens?
I have this somewhat net new conspiracy theory that I actually think that what we're seeing is actually an intelligent life that lives on our same planet, but it's Atlantis style, under the Pacific Ocean. Because if you look at it, there's basically a whole half of the Earth. You can actually look at the Earth. If you look at just the Pacific, it's basically literally almost entirely water, and it could have not been water.
Sentient dolphins, just
or something that we some off branch of humans that discovered some set of technologies 10,000 years ago and advanced very rapidly in isolation, and then decided to isolate themselves.
Would you give that a percentage chance?
Hard to give betting odds, but I don't know, 15%.
But you think majority it's some military vessel or something? Or
No, not necessarily. I think it could be some sort of radio anomaly, some sort of physics phenomenon that we don't appreciate or something, where it's ball lightning or something like that, where it's just some crazy freak edge case of electromagnetism that we just don't totally understand yet. So my guess is more freak, edge case of the universe.
But you're convinced it is a real physical phenomenon that people are
no, I think there is a real physical phenomenon. There's way too many instances of this, but I'm not convinced that it's necessarily an intelligent thing that is causing it.
Back to our serious part of the what's the Air Force and what's NASA paying you for? Or what are these contracts given that you're still in the early development of manufacturing?
Yeah, so the Air Force and NASA are not paying us for anything manufacturing related. Basically, if you remember, I gave that sort of 3-part spacecraft summary before: the satellite, the manufacturing, and then that reentry pod. That reentry pod has been of significant interest to various groups within the government, because basically when we're coming back, because we don't have any humans on board, we come back basically at much higher sort of speed, G-load, sort of heat flux, basically the amount of thermal energy that's being, sort of created than what a vehicle that has typically humans on board. If you think about the ones that have humans on board, they're kind of trying to surf their way into the atmosphere so that they just steadily slow down and that the, astronauts don't experience too many G-forces and they keep everybody alive. Whereas we don't have any humans on board, so we're just screw it, rip it, just dig right in. And so because of that, we experience an environment that is very useful both for groups like NASA to basically test out new heat shields that they want to use for a Mars mission, as well as groups like the Air Force that want to actually be able to use this as a way to basically test out, for example, they want to build hypersonic interceptors to intercept, China's basically hypersonic boost glide space missiles. And so they use us as a way to test out, okay, how do we build out sensors and navigation equipment and heat shields and wing shapes and things like that. So you can kind of think of it as imagine you were trying to build an airplane before there was a wind tunnel, and every single time in order to test it, you basically just had to throw it out in the air. That's basically what we're doing anytime we're trying to build these hypersonic interceptor systems. And so we're basically that wind tunnel where instead you go and basically test things out so that when you go and build the full hypersonic interceptor, you feel really confident. And so if the Wright brothers or Boeing didn't have a wind tunnel, it'd be a huge pain in the ass. Right now it's a huge pain in the ass for the government that they basically don't have a hypersonic wind tunnel, and Varda is basically the sort of closest equivalent to what you can get to a hypersonic wind tunnel given how quickly we come in.
The wind tunnel is the experiment that they can test like they would in a wind tunnel, or
we are the wind tunnel.
Or they're literally following behind you and using...
They're imagine that our reentry capsule is the wind tunnel. They're inside the capsule being tested. So the capsule is the wind tunnel.
Blocking it.
Yeah, exactly. So they might test different things. They might test a wing inside of that wind tunnel. They might test a piece of sensors and equipment. It's basically each of the various government customers has different things that we test, and we figure out where to put them in the wind tunnel so that it gets the test that they want, basically. And so we basically do all our pharma manufacturing, and we come down, and if we just only had our pharmaceuticals on board, we just look like a sort of boring reentry capsule, and instead we have a bunch of things sticking out in in various places, basically to test out for the sort of DoD and NASA.
What's your, and I don't know how open you would be on this now that you have government contractors, but what's your general view of what pieces of space are best for private industry and which parts are best sort of in government and like how effective you think sort of NASA is today?
I guess if we're gonna go like NASA specific, rather, I thought you were asking like a broad government question, but for NASA, if I were to, sort of give a general, sort of pitch and philosophy on what I think NASA should be doing, I think they should continue to lean into the things that are just like very far out and difficult, true basic research and science. So it's like, lean into like helicopter on Mars, super like probably the coolest thing that humanity's made in like the past 2 or 3 years. Like take that like little drone and turn it into like human scale helicopters that like, when we land humans there, we're doing that. And they are starting to already like work on that. That team is getting like,
I had no idea.
A huge boost in, funding,
just like a helicopter works in Martian atmosphere, basically.
Yeah, we've already proven that. So, they landed a mini helicopter alongside the rover in the last Mars rover mission. That helicopter has now been flying for like, forgive me if I'm mistaken, but I probably guess like 15 or 16 months or so. It has covered like more ground than all of our rovers over the past 30 years, like combined basically, because it flies. And by the way, it flies on a different planet. Like that is a thing that humanity has done. We've like made it. And by the way, in order to fly in like that thin of an atmosphere, like it's like wingtips are going like Mach 4 or something like that. So it's like, I call it a helicopter, but it's like closer to like a like jet engine helicopter that, is like just spinning crazy fast blades. But yeah, it's like really like they have like a video where they basically had the rover filming the helicopter taking off and landing. So like there are like videos, not from like, it has onboard cameras that are like pretty good, but there's like an offboard camera, like the rover that like does it. And like watching a video of a helicopter on Mars is probably like the coolest experience one can have.
So NASA do that. Okay.
Yeah, keep doing, sort of that stuff. And then they have a portion of their mandate, which is basically like kickstart the like, economic flywheel of humanity expanding into space. They did a really phenomenal job of that with basically like launch services, right? So basically like rather than saying like, here's how you should go build your rocket, here's how you should go basically like resupply the International Space Station. Instead, they said, we'll pay you like, $50,000 per kilogram that you get to low Earth orbit, and we'll pay you $200,000 per kilogram that you basically like deliver to the International Space Station. Do with that what you wish, basically. And so that's how you've seen the success of programs, like commercial resupply, like commercial launch. And so now they're starting to think about how they do that sort of basically for future programs. And I think they should continue to have this like split world where basically like anything that is sort of like close to Earth and in the realm of what like venture-backed companies can do, they should basically just act as the first buyer in the marketplace. And that's what kickstarts the supply so that, in the early days, maybe NASA was buying most of SpaceX's launches, but now companies like Varda can buy SpaceX's launches. Do the same thing for these like, sort of commercial services. Be that first like guaranteed buyer. And then don't focus on engineering as much there, just be a buyer, and then focus all the engineering, basic science, et cetera, on the things that are like super far out.
Like who do you think would do a Martian mission? Like the government or SpaceX?
Right now, it's just the government that is like, sort of planning on those. And I think that is the place where they should continue to plan. Same thing with like, the first lunar base will be, done by the government as well.
I feel like one of the challenges when NASA or like the government does something, like I feel like every American can feel like some sense of like ownership over it because it's like their money, it's their part of it. In some ways, like, I don't know if I'm incriminating myself with this view or not. Like when SpaceX does something, it can feel like you have to like go and like say Elon's great. Like it's almost like you're obligated to like go thank this sort of like strongman billionaire instead of when the government like does something, it feels like, oh, that's like us. Or like, do you think there's like part of the barrier to sort of national, sort of popular embrace of sort of the space exploration stuff is that it's private enterprise and that it's done in a way that sort of the regular person feels like irrelevant to?
Well, I mean, there are plenty of political polls that show that Elon Musk is the most favored like public figure in the United States. So I would argue that your entire thesis is flawed, basically, which is, Elon does the best job of any figure of making the public populace feel like a part of space exploration, even better than any other government.
But it's very much like it's a strong man. Like he gets the credit for it. Like even more than like the SpaceX engineers and stuff. It's a very central, like the story that humanity's telling is one of the brilliant sort of Elon Musk taking us there.
Yeah, I mean, and that's
collectivist.
Always been true in history is that like stories are like the great man is always the easiest like sort of story to tell rather than the collective. But yeah, I guess I'm not sure entirely where the, sort of like how to answer the question.
I don't know. Yeah, it's not a very pointed question. It's just something I'm like, I struggle with. Or it's like on the one hand, yeah, I guess I'm not going to let ideology get in the way of cheering for something that I'm excited
Yeah, I guess
for.
it's like struggling with like the sky being blue. Like I would say, like, go talk to your therapist, but like, it's like a law of physics. So
I assume you watch Oppenheimer. Like, I mean, the reality of SpaceX is that there are a lot of people like doing it. He's doing a lot of things. Like, some of it is there's sort of the myth building around one person, but the reality is like they are collective endeavors. Yeah, I don't know. I feel like just like the stories that are paired with, the scientific accomplishments of our time is interesting.
you're the one telling the stories.
Yeah.
Change the narrative. Go interview
You're telling the stories as well. I mean, yeah. I feel like
we highlight our team
control-
members.
Right.
We have Andrew McCaleb, out and doing public interviews and talking about things. We, I think, do a pretty good job of like highlighting like the broader talent of Varda beyond just like the founding team. And I would, put it on the media of like, I don't know, like The Information did like this like profile piece on Gwynne Shotwell, who's like one of the most like phenomenal executives, in the space industry. And like her article was like half like a takedown article. So, I would put it on like the onus of like, yeah, media and journalists should do a better job of like recognizing that there are a collective of people that contribute significantly to SpaceX, and they aren't highlighted or appreciated well enough. Like, people should be banging down Gwynne Shotwell's door to be like writing books about her, and people don't.
Right. I'm sure. Well, I would happily write a book about her. I feel like she's probably hard to access, but yeah.
Maybe because people write takedown pieces about her.
I do think there's, the media can't sort of help itself but sort of have sort of a negative angle at any given moment. It does feel
For some reason, media loves to
knee-jerk.
destroy powerful women. I don't know why.
Do you think it's women specific, or it's just, I think stories.
There's definitely a trend of
Right.
like every strong woman founder, every strong woman like aerospace leader like gets torn down by the media for some reason.
Yeah, I mean, I agree. There's no quibble on that there was like, especially, the startup founder period.
Yeah, like the Away story, the Outdoor Voices story. Like, there were so many of these that were just like complete nonsense.
Do you think, are you supportive of like Musk's time spent on X, Twitter, like, or do you think it is sort of a detriment to SpaceX?
I think he's a phenomenal entrepreneur, and it's not up to me to judge where and how he spends his time. If he's like most intrigued by and thinks that like X is going to be the most impactful, like, good on him. And I think he obviously is still a phenomenal visionary and leader for SpaceX, but also the company is like in a very mature state where it has a really great set of leaders, including people like Gwynne Shotwell, and seems to be making really phenomenal progress. So I don't think that like the marginal hour that he spends on like Twitter is somehow like preventing Starship from coming online or anything like that. So I think Starship is just like a very difficult project, and that is just going to take a series of cycles and iterations, and it's really exciting to see what's happening at Boca Chica and the progress that's being made there. But I don't think that like Twitter is somehow, preventing that progress from happening.
You got promoted at Founders Fund recently.
Yeah. And it's like new set of funds. And I think we announced it, late May, June timeframe.
How do you do both? Or like, it's certainly a lot of time.
Yeah, I think it's mostly that like 1 + 1 = 3 in that, I think part of what allows me to, I think do decently in both roles is there are times where when I'm working at Varda, there's a huge, sort of upside to having the Founders Fund, sort of brand and the like investing, sort of hat on, whether it be when I'm fundraising on behalf of Varda, when I'm on Capitol Hill meeting with particular, congressional figures that may have a lot of respect for the Founders Fund name, but may or may not have actually heard about, Varda quite yet, to my ability to understand the broader landscape and, how things are going in aerospace, in the aerospace world, given that not only do I know how Varda's doing, but I also know how a lot of the like, near peer companies are doing as well. And so that really unlocks an insight of like, where are we in terms of headcount, burn, revenue, et cetera, relative to like, sort of certain peers. And I think having that broader perspective makes me very effective at Varda. And then on the flip side, on the Founders Fund side of things, being the man in the arena, I think is a thing that makes me both the most helpful to founders that are starting companies and just significantly increases the like, sort of top of funnel of people that are interested in working with me, conversion rate, all the way down through making investing. So although over the past, since starting Varda about 3 years, I've definitely spent less time on the investing sort of role, I actually think I've been able to sort of deploy at just as high of a pace and with just as great of IRR, if not higher, than where I was sort of before. I think it's a unique setup for two reasons, which is, one, obviously being a part of a platform like Founders Fund that is very encouraging basically of this type of role, right? If you look at our team, it's almost like half the team now that is in this type of role where they're actively basically building something alongside investing.
Ryan Peterson, the chairman of Flexport. Yeah.
Trey Stevens, Keith Redboy, I'd argue Peter Thiel as well. And then, I think the other thing that's...
What's Peter's company?
I can't claim that I have a specific one in mind right now, more that he does spend a lot of time with certain like biotech companies that this has been publicly reported on where he's like, chairman, and I'm not like super deeply familiar with it, but there are like a handful of biotech companies where he goes like very, sort of deep.
The life extension type or?
I don't think any of them are life extension related. One of them was like an antibodies company, but I'm not even like that deeply familiar with the company. But
Okay, anyway, sorry.
Oh, yeah, no problem. What I was going to say is I think, at least when I think about when is it sort of worth incubating something and actually, subjecting yourself to the torture of two jobs, when you, I think, fit a certain set of criteria. One is the company that you're going to incubate isn't something that is already available on the market that you could just like invest in, given that the opportunity cost of building something is like massive. Two, it's something that is like uniquely suited to be incubated and built by a venture capitalist, in that it's something that either like your ability to fundraise because it's capitally intensive, or your ability to put together disparate talent that may not come together otherwise makes the company possible. And then third, ideally that this is a company that is also in a category that you're highly interested in investing in, so that by basically working deeply in this category, you can assess things more easily and you get basically the best top of funnel. And so for me, Varda sort of fit all three of those categories where there wasn't really anybody working on it. It's going to be capital intensive, and I can help basically put together the financing that's necessary. And three, I was highly interested in investing even more in aerospace than I was before. And so what better way to basically have as much top of funnel and like access in aerospace than starting a company? And so I think, it's rare to, to feel very, sort of fortunate and grateful to find myself in this situation where I am able to balance these two. I think there's sort of a million different variations of this that, wouldn't quite work, but the particular variation that I'm in right now sort of happens to work.
What are your main investments?
At Founders Fund that I've made. If you look at top performing over the course of my entire investing career, both at Founders Fund and at Coastal Ventures. At Coastal Ventures, I led the Series A of Sword Health and then continued to double down at it from Founders Fund. That company was last valued at roughly $1.8 billion. And we originally invested in the Series A at 25 posts. And then at Founders Fund, when I moved over at, I believe, like 40 posts. I also, worked alongside Keith, but did source Ramp Financial, their original, basically both seed and Series A round. Was the point person on both of those, where we originally invested, again, in similar roughly price points to Sword. And ultimately, obviously, that company was last valued at $8 billion in their last financing. So those are probably the two, let's say, sort of unicorns, and there's a whole, set of like, let's say, mid-stage companies that are, tracking relatively well. Lula, for example, an insurtech in Miami, just announced their Series B. Hadrian, another aerospace company, sort of down the block, Cover, this home building company in LA. Those are some of the examples in the mid-stage range.
Don't want to deprive our listeners of your wonderful tweets. You had a great one. Imagine having to wake up every day and work in SAS, while the world is regularly landing orbital rockets, breathing life into silicon, and synthesizing superconductors using alchemy. And then Rune, always the troll, says, now tell us how you really feel about corporate cards. Are you guys writing off SAS? Or like, I mean, I know that just comes from you, but what is sort of the view over a Founders Fund on software investments right now?
That's very much so my personal view, and it more has to do with my personal motivation than necessarily, where IRR is. Obviously, we've hired some phenomenal folks, including, Sam Blond, who is formerly, CRO at Brex, that, his primary focus is in, sort of SaaS, and previously had, phenomenal SaaS career before Brex. So no, not something that we're...
guy, Parker.
Yeah, he was at EchoSign back in the day under Jason Lemkin,
Yep.
And then was at, Zenefits with Parker, and then Brex with Henrique, and I forget the other guy's name, at Brex, and then joined us. So no, not at all. Obviously SaaS is something that we're going to continue to invest in. It's just something that I personally at least prefer to, not spend time on. So I'm very glad we've hired people like Sam that can go get all the returns.
Somebody shit on you in the replies saying, didn't you sell t-shirts for 7 months or so? What was that? I didn't even know that about you, or what it was your 7-month
Oh yeah, I worked at Teespring for about 8 months.
Oh yeah. What'd you learn from that experience?
I did learn a lot. It was one of these examples where I was at the time, I believe, 22 or 23-year-old, like single-time sort of failed founder. The company was in a little bit of a floundering state where they basically had a very highly priced, and they were flying high. Let's say they were like the hot startup darling of Silicon Valley in the, call it 2015, 16 timeframe. And then basically shortly after that round, they basically like flatlined in revenue for the next like 2.5 years, if not slightly declining revenue. And so there was interest in, sort of making some more risky moves. And so one of those moves that the board was, convinced of was, let's give this 23-year-old, single-time failed founder like a whole department of the company, just like see what he does with it. So I really enjoyed it. Like, I think I did a decent job of also like drinking the Kool-Aid while I was there. So I really believed in t-shirt selling, even if, looking back, maybe it's not the most exciting thing, but I was really appreciative for the opportunity to like get to lead the largest team that I think to date is still the largest that I've ever led in terms of like the number of direct reports that I had that reported into me, and managed to grow, sort of the revenue line that I was handed from like roughly 12.5 million annualized GMV to about 75 million annualized in GMV. And so I learned a ton during that time about just like how to manage, how to be an executive,
Did
president.
Teespring exit or whatever happened? That was like
I believe there is still
January
a privately held company, and they've been like EBITDA positive actually basically since roughly the quarter after I left. Basically, we like went through a riff around the same time that I actually decided to leave, and the company has actually been profitable now for an extended period of time. And some of the stuff that I actually worked on back in the day, some of the things that are actually like working the best for the company now. So it's cool to see that finally play out.
What's your political involvement these days? Or I'm very happy that we've made the piece you've come back on. Like our first, I think, Silicon Valley encounter was over that like Chesapeake thing when we were all going crazy during the Clubhouse era. But then we got to see each other at Web Summit, and I think both are Twitter. Well, you're much more feisty on Twitter than I am, though I think also my combativeness and time spent on Twitter has calmed down. But are you active in, looking out for the presidential candidates or San Francisco politics stuff these days?
Yeah, I think at the time I was deeply passionate. Back in even 2018, I want to say, I actually was 2019. I was actually one of the largest fundraisers for Leif Douch, who was one of the DA candidates. I campaigned for him, spent a ton of energy and resources, sort of personally trying to get people to understand basically why this race was very important. I couldn't get like the light of day from anybody, including people like Solana, for example, who came around to how important it was. But at the time,
that's Mike Solana, who's also at Founders Fund and writes, what's
Pirate
his
Wires.
Newsletter called? Oh, Pirate Wires, which is always fascinating, worth at least having on your radar if diametrically opposed in stylings to
Exactly. But yeah, nobody really paid attention. And so that was definitely, at least for me, my breaking moment with like basically interest in San Francisco, sort of politics, and that I felt like I put in a ton of effort and like nobody in the tech community was basically like paying any attention, sort of to this. And it ended up having a real impact on my life, and obviously ended up, sort of deciding to move away almost like 2 years to the date after, that campaign to Miami. So yeah, since moving to Miami, obviously I don't feel like I have much incentive to care much about San Francisco politics. I mean, credit to like
I'm sorry, Varda's in California, though, right?
Varda's in Los Angeles, where I do about like 4 months of the year, and then 7-8 months of the year I'm in Miami. Anyway, so credit to folks like Gary Tan, and then I forget the guy's name, Sachin with like Grow SF. I'm maybe not pronouncing his name correctly. So it's really great to see some people that maybe are starting to get sort of more traction, although still doesn't seem like there's sort of been the change that people have been sort of hoping for. And then, beyond that, sort of particular incidents, I'd say I'm definitely not opposed to, sort of becoming more politically involved over time, but at least right now, very narrowly focused in on basically Varda. And so all of my political contributions go into the Varda PAC. All of the Varda PAC contributions basically go to our, particular company policy priorities that are very specific to, basically our work around reentry, hypersonic testing, sort of the future programs of NASA.
All right, great. Thanks so much for coming on the show. This was awesome.
Cool. Thanks for having me, Eric.
That's our episode. Thanks so much to Delian for coming on the show. Shout out to Juniper Square, our sponsor for the episode, Tommy Heron, the audio editor, Riley Kinsella, my chief of staff, Annie Wen, who's producing for the summer, and of course, Young Chomsky for the theme music. Like, comment, subscribe on YouTube, give us a review on Apple Podcasts, and please subscribe to the Substack, newcomer.co. See you next week.
Goodbye, 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 goodbye.